In this video, we'll look at ways of displaying data. There are many ways to display data depending on if the variables involved are categorical or quantitative. First, let's look at how we can display categorical data. Suppose a middle school math teacher is teaching a unit on statistics, and they ask each of the students in their class, "What was your first pet?" and then they record the students' answers. We can report the data in what's called a frequency table, in which we count how many times each response was given by a student. While this certainly summarizes the data, it often helps to present the data visually instead. One way we can do this is using a bar chart. Note that we could have placed the bars in any order since our variable is categorical, but we have to make sure to label the bars. Another thing we could do is total the number of responses. In this case, there are 20 responses, one for each student. Then, if we divide each frequency by that total, we get what's called the relative frequency. That is, the proportion made up by each response, which we can represent as a fraction, a decimal, or a percent. Using the relative frequency, we can visually present the data as a pie chart, which makes it even easier to compare what proportion of the class had each response for their first pet. Notice that all of the proportions have to add up to 1, or 100%. Now let's look at how to display quantitative data. Suppose that same teacher gives their students a test at the end of the statistics unit. Here are the scores from least to greatest, ranging from 35 out of 50 to 50 out of 50. Again, all these numbers are likely to make someone's eyes glaze over, so it would be preferable to display the data visually. One of the most common ways to do this is with a histogram. A histogram is a lot like a bar chart, except instead of each bar representing a certain category, it represents a range of values. When writing those ranges, we use a square bracket to say we are including a number, and a round parenthesis to say we aren't including a number. So this first range from 32 to 36 does include 32 because it has a square bracket, but it doesn't include 36 because it has a round parenthesis. Perhaps we could have just written this as going from 32 to 35, but that really only works when everything is a whole number. If there are decimals involved, these brackets are the best way to go. So our histogram tells us, for example, that there was only one student who scored less than 36 out of 50, while there were 8 students who scored a 48 or higher. Another way we could display quantitative data is with a dot plot. On a dot plot, each individual data point is represented by a single dot, and those dots are stacked on top of each other. Unlike with a histogram, we can see how many people got each individual score. But dot plots can get unwieldy with large sets of data, so it's better to use them on small data sets. One more way we could display quantitative data is with a stemplot, also sometimes called a stem and leaf plot. A stemplot is also a lot like a histogram, but we use the digits to sort the data into bins. Here we use the tens digit as the stem and the ones digit as the leaf. We usually provide a key to show how to read the data. So for example, the first row shows us scores of 35, 36, 36, and 38. Sometimes if a stem plot gets too unwieldy, we can divide it a bit further. Here we've divided the scores in the 40s so that everything from 40 to 44 is in one row, and everything from 45 to 49 is in another row. These aren't the only ways to display data, of course. We'll learn about another one called the box plot pretty soon. Something you might want to ponder is, what are the advantages and disadvantages of each type of data display? When do you think one would be useful versus another? So the next time you read a scientific paper or open up a news article, be on the lookout for these ways that data can be displayed, and ask yourself why the authors chose the display they did to get across their message.